Everyone, I think I'm live now. Can anyone confirm if audio and everything is fine before we get started? Like, although I ended up solving all the problem, I am particularly not a fan of this problem E today. And essentially, that's where we are. So, like, it was more proof by AC, and like, only when I brute forced it for small test cases, I found like, apart from n equal to 1, there are just 24 solutions for the given constraint. And like then like you can either brute force them or you can just hardcode the answer or whatever you want over there. So like just one check, can anyone confirm if audio etc everything is fine before we get started? And like how many guys people in the chat were you able to solve? Like that will give me some idea of like which problems to focus more for today's stream and which we can probably move fast. Yeah, like thumbnail I am yet to update it. Like generally I update it after the contest. Yeah, I can probably go and update it, but yeah, that's where we are. And like the internet is probably also a bit flaky today. Oh, solved 6, nice. So probably I will just quickly go and change the thumbnail, but ABCDE plus. Okay, I think the thumbnail should be updated now. And like first question, like yeah, I will start from first only. Like the plan is to go from 1, 2, 3, 4, 5. So like let's probably get started now. So the first problem, like I will for all the names, I will just read out the first name, like because like they ended up using usernames there, and I probably don't know how to pronounce those names correctly. So K has written three integers A, B, C in the order to remember that he has to give an A into B into C bananas. N has found these integers and decided to do the following at most 5 times. Pick one of these integers, increase it by 1. For example, if A equal to 2, B equal to 3, and C equal to 5, one can increase A 3 times by 1, B 2 times. After that, A would be 5, B would be 5, C would be 4. And total number of bananas would be 5 into 5 into 4, which is 100. And it asks us to print like the maximum value over there. So like there are multiple ways to do it. So like if I read the problem statement correctly, for problem A, it says we have been given three integers A, B, C in one operation. We can take any one integer and increase it by 1. We can do this at max 5 times, and we have to print what is the maximum value of A into B into C after at the end of the operation. So there are multiple ways to do it. For example, you can have 3 for loops for I equal to 0, I less than equal to 5, I plus plus. I denotes how many times we should increase A. For j equal to 0, I plus j less than equal to 5, j plus plus. J denotes how many times we have to increase B. And for k equal to 0, I plus j plus k should be less than equal to 5, k plus plus. And now like new value of A would be A plus I, new value of B would be B plus I, new value of C would be C plus I. And you can maintain a variable answer, which now you can take max with. Answer equal to max of answer comma and new value of A, new value of B, new value of C, and so on. That this is one solution over here. And another solution like I had was, a lot of people would have done this. Yes, like as someone EMC square pointed out, like one way to do is like always increase smallest number. The idea is like if you look at the value, if you increase A by plus 1, answer increases by B into C. If you increase B by plus 1, answer becomes A into C. Like new value of like answer is A into B, A plus 1 into B into C minus the old value if you look at. So like this difference is B into C. And if you increase C by plus 1, answer becomes plus equal to A into B. So the greedy idea is if you increase the smallest number, let's say this is the smallest number. If this is the smallest number, then this will be the maximum value you will increase in one step. So that was one solution to do it. And the idea was to just sort vector A each time and then keep looking at the value. So like these are the two possible solutions for the problem A. So any questions on problem A before we move to the next problem? So in context, I took all the integers as input, ran a for loop 5 times, sorted all the number, increased the smallest number, and keep doing, at last print the value. This is one possible solution. And like there would be one with for loop as well. Like I can probably show that as well. This is also just sorting the number into like. Yeah, like this is another solution we have. Read integers A, B, C. Initial answer is A into B into C. Number of times you increase A, number of times you increase B, number of times you increase C. If total count of all of them is less than equal to 5, print 1 into new value of A, new value of B, new value of C, and print what our answer here. That was one solution. Like the second idea here was, like let's say we increase A by 1. Then this would be the new value of answer, new value of product. And if you look at the old value of product, which would be A into B into C. And their difference, if you look at these two values, it is B into C. So like when you increase A by 1, the difference, like the value of answer increases by B into C. If you increase B by plus 1, similarly you can try out the argument. Like new value of answer would be A plus B into C minus A into B into C. And if you look at this difference, like this becomes A into B into C, like splitting it over here, plus A into C minus A into B into C. And like this cancels out, and this value is A into C. So the idea is like if we increase B by plus 1, answer becomes plus equal to B into C. Answer becomes one second. Looks like I'm messed up with my shortcuts here. Left click. This is hand. This is left click. 1 second. K1 is shift. K4 is left click. K2 is left click. K3 is control Z, shift here. Okay, got it. 0, 1 should be, shift is not required. K7, K6 is required. Okay, here basically the idea was, if we increase B by +1, our answer becomes answer plus equal to A into C. And like that is the crux of the problem. So if we increase the smallest number, then our answer would be increased by maximum in one go. And that was the motivation behind always increasing the smallest possible number. And like, control Z and K6. Any more questions or anyone who did not understood the idea of first problem before we move to the second problem? Okay, now moving further, I will move to problem B. Problem B says to celebrate his recovery, K has baked an enormous 10-meter long potato casserole. Turns out N just can't stand potatoes, so he decided to ruin K's meals. He has cut it into K pieces of length A1 to AK meters. K hasn't keen on that. Luckily, everything can be fixed. In order to do that, K can do the following operations. So, like nothing much. Like now, like what we know is like we have been given an array of length K, such that sum of values of all the values in the array is N. And what we can do is like we can pick one of the element of A and divide it into two elements, 1 1 and 1 AI minus 1. And as a result, like the number of pieces increases by 1. And what we can do is like we can pick two different pieces where one of them is 1. We can also join them, and as a result, number of pieces decreases by 2. Now what it says is like for given elements, like find the minimum number of operations we need to do so that we have final n value with us. Like what we have is a1, a2 up to ak given some k integers. And now like what we can do is like in one operation, we can take some element and change it into two different elements. One of them would be 1 and another one would be a2 minus 1. Or what we can do is like we can pick some 1 in the array and some other element in the array. We can combine them to form a new element, ak plus 1. And what we want at the last is one final element, only one element which is equal to n for us. And it asks us to do minimum number of operations. And the idea here is like if we look at any value, let's say 5, And let's say we don't want this element to remain at last, then what will you have to do? Like we will have to change it to 4 1 first, split it 3 1 1, and if we keep doing it 5 times, we will have 5 ones at last. 5 times, or no, 4 times this operation would be required. Like if we want to split in one operation, we will split it into 4 1. In second operation, it would be 3 1 1 and so on. After 4 such operations, we would have 5 ones. And now, like we can combine it into some another element by doing operation 5 times, some age. So overall, we need 9 operations to combine this 5 into some other element. Any questions so far before we proceed further? How 9 one more time? Like the idea is like if we don't want this 5, if this 5 should be merged with some other element, then first this 5 should be splitted into different elements here. Like first time when you split, it will become 4 1. Next time you split, it will become 3 1 1. Then you split, it will become 2 1 1 1 1, and then after that 2 changes to all 5s. So using 4 times, you will get all the ones here, and then now you have 5 different ones, and you can do combine operation for each of the elements. 4 steps to split and then 5 steps to join something else. That's how it gives us 9. Or what I can say in general, if we have an element x, we first need x minus 1 splits and then x combine operation. And like that is the first idea I have. Any questions on this? Yeah, like now the idea is like if some AI needs to be merged with some other J, we need 2 times AI minus 1 operations. So now we can use DD. We will keep maximum and merge everything else. Into it. And that is the main idea. Because now you see like, because for every element we know how many operations we need to merge it into something else. And maximum number of operations would be required by element which is maximum. So what we can do is like we can keep that element and everything else can be merged into that element. And like that is the main idea. So like for every element, like if for every element except merge maximum, we would need 2x minus 1 operations for them. So we can sum it up for all the element except x not equal to max. There can be multiple max, so you have to take care that you only count it only once. And like that is the solution I have. So I took all the integers as input, I sorted them and I removed the last element. You can, and then for every other element, I counted number of merge operations required, number of split operations required and printed it. And that is the solution I had for this problem. Any questions on this problem before we move to the next problem? We can say A dot pop back. Any questions on problem B before we move to problem C? Okay, I will move on to the next problem then. Next is problem C, which says gorilla and permutation. G and N found three integers and M and K, and they decided to construct a permutation of length n. Permutation means all the elements from of length n means all the elements from 1 to n appears only once in the array. And because we have to print the permutation, like all the value we print, every number from 1 to n should be there only once. And you can see like it satisfies here. And for the permutation, n came up with the following function. G of I is the sum of all the numbers in permutation on a prefix of length I not greater than m. So what it says is like, let's take some examples here. Let's pick some example permutation. Something 3, 5, 6, 2, 1, 4. And like, let's say m is equal to 3. Then it says like G of 4 means look at the first 4 elements. G4 means look at the first 4 elements. See all the elements less than equal to m and find their sum, which in case would be 2 plus 3, which is 5. So G4 would be 5 if m is 3, and this is the permutation we have. Similarly, G came up with function f, where f of I is sum of all the elements in the permutation of prefix of length I that are not less than k. And let's say k is 4 here. Then it says like f of 3 would be look at first 3 elements and all the elements which are greater than equal to 4, which is 5 and 6 in this case, take their sum. So f of 3 is 11 in this case if k is 4. So any question so far, like what is f, what is g? Then I will move to the other part of the problem statement. Like given some k and m and a fixed permutation, how do we find g? How do we find f? Okay, full screen F11. What I am saying is, probably 1 second. So like what it says is like, what we define is G of I as take the first elements of the permutation. So if I want to find G4, I would take first 4 elements G4 means, and let's say M is given to us as 2. Take first 4 elements of the permutation. Which in this case, these are the first 4 elements. And if M is 3, like we say we want to find G4 and M equal to 3 is given to us. And this is the permutation we want to look at. Then among the first 4 element, look at all the numbers which are less than equal to 3, which here is 3 and 2. So take the sum of these 2 elements. 2 plus 3, which is 5. And that's how G4 is 5 here when M is equal to 2. And now the next idea is, like, let's say K equal to 4 is given to us and we want to find F3. So what we have to do is, like, we have to look at the first 3 elements here, which in this case these are the first 3 elements. And if K is 4, then look at all the elements which are greater than 4, which is 5 and 6 in this case. Take sum of 5 plus 6, which is 11. And like that is how given some permutation, M and K, we can find F of I and G of I. Any questions on this? So now the next idea is, it says, like, take sum of all the values from F1 to I and subtract it from all the values of G from 1 to I. And what is the maximum possible value you can get? So the idea is, and one important thing was, like, M is less than K is given to us. And like M greater than K is would be critical. Because if you look at 1, 2, 3, 4, there would be somewhere M here. Then there would be some elements, then K would be here, and then up to N elements would be here. So what it says is, like, these numbers should be added in every permutation and these numbers should be separated. So now what you can see is, like, you can do a greedy idea. In the first element, pick N. So N is present in every permutation. Like, the idea is again greedy. Pick N first, so that N is present in every permutation. Then pick N minus 1, so that it is present in N minus 1 different permutation, and so on. You can go up to K. This element then would be present in N minus 1 K permutation. Like printing N, N minus 1, N minus 2, and so on. Now these are the elements which will not contribute anything, and this would reduce our answer. So, like, we can print these numbers in any order. And then, like, we want small sum to be reduced at each point of time. So the idea is, once you have filled all of these elements, you have filled N minus 1 M elements. So print 1, this will add M as a contribution to the minus M as a contribution. Then fill 2, so it will take minus 2 into M minus 1, and so on. And at last print M, so final value prints M. So my proposed solution is print from in descending order first, n minus 1, n minus 2 up to k. Then print numbers in any order which are greater than m, which are between m plus 1 and k minus 1, and then print 1 to m in ascending order. And like this would be the permutation which will give us the maximum possible answers. Any questions on this before we move further? And essentially this is the solution. So like what I did was I also printed these numbers in descending order. So the solution looked like print n to m plus 1 in descending order, then 1 to m in ascending order. Print all the numbers greater than 1 in descending order, then print all the numbers in ascending order and print the permutation, and that was the answer for this problem. Okay, I will move to problem D. Problem D says E is ready to do anything for J, even to swim through crocodile infested swamps. We decided to test his love. E will have to swim across a river with a width of 1 meter and a length of n meters. The river is cold, like what it says is, what it says is we have 1 to m, a river of length n. Somewhere is standing here and he wants to reach here. And like it is cold and like you cannot swim for more than k meters. Like what it says is like we also like at some places water is there, at some places a lag is there, and at some places crocodile is there. Water, crocodile, lag, water, lag, crocodile, let's say something like this is there. So you cannot swim in water for more than k times. You should swim for less than k times. So like you have to go from here to here, but you cannot go in W for more than k times. You can never go to C. Going to C is not allowed. And if you are on surface, lag, or somewhere, like if you are either here, or at L, you can make a direct jump. River is very cold, therefore in total, that is throughout the entire swim from 0 to n plus 1, E can swim in water for no more than k meters. For the sake of humanity, we have added not only crocodiles to river, but also logs on which he can jump. Our test is as follows. Initially, E is on the left bank and needs to reach the right bank. They are located at 0 and n plus 1 meters respectively. The river can be represented as n segment, each of length of 1 meter. Each segment contains either a lag L, crocodile C, or water W. E can move as follows. If he is on the surface, that is bank or the lag, he can jump forward for no more than m meters. So in one go, if he is on here, let's say, or if he is on lag or here, he can make a direct jump somewhere, but that distance should be less than m, less than equal to m. If he is on water, only option he has is to swim to the next segment. So for example, if he is here, the only option he has to go here, and which fortunately he cannot go to crocodile. So that's not a good idea. From here, like he can make a jump, but he can either go here. From water, he can only go further. And from here, like he can make a jump, something like that. He can not land in a segment with a crocodile anyways. Determine if he can reach the right bank. So the question asks us to say whether we can go from here to here or not. I will take some samples to illustrate. First sample says we can jump 2 times, but we can never go in water. Like that is not a good sample here. Probably anyway, let's take it. So first sample says we have a log, water, log, 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 water. We are here and we want to reach here. We can never swim in water because the value is 0, and we can make 2 jumps at a time. So the idea is from here directly jump to this element. Then because we can never swim in water, the only option we have is jumping Japan. And that is how the answer is yes. This is the route we can take. Someone asked to explain third test case. Third test case is LWLLWL. We are here and we want to reach here. And what we can do is like we can swim in water only once because M is 1 in the third test case. And we can also make a jump of only size 1. So like a lot of people would have printed yes here. Because like if you see here, you can jump from here to here of length 1. Then if you make a jump 1, then you go further here. Here make a jump 1, make a jump 1, go in water here and make a jump here, right? This looks fine, right? All the jumps are of length 1. And when we are swimming, we don't go more than 1 at a time, right? But what it says is like total swim should be less than equal to K. So we can swim only once here. And because here we are swimming twice, the answer is no here. And like that was the critical thing. It says therefore like in total, that is throughout the entire swimming from 0 to n, E can swim in water no more than K times. So like why can't greedy solve the problem? Like you have 2 things to minimize. Like you want to minimize the number of waters there, and like the only option is like you see from where you can jump. Okay, you might be using some dark theme, I think so. So like greedy, like I don't have an immediate counter test case with me. But like to me, like doing a maximum jump always cannot be the right solution. Like I can try to give some example. Let's say from here, this is the maximum jump you can go. And then there are some crocodiles here. Like the idea is like sometimes you can take smaller jumps to only go via water. While if you take a maximum jump, you may reach somewhere here, then you may have to swim for some segments. And from here you may reach here and you have to swim for some segment. while it may be optimal to always make jumps somewhere. And that can be the counter test case. Okay, Neil is here. Like Neil says maximum jump is correct as long as we prioritize going to logs over water. Yeah, like that can be probably, I did not write, but yeah. Yeah, congrats Neil for winning today. And like what I did was like I went through a DP solution. Like my idea was to go through DP. DP ID nodes. We have started from somewhere. Like we started from here. Like we have moved to the ith log from here. And what is the minimum time of times we went to a water? Minimum swimming time. And like essentially that was the solution I had. And the idea is if we are at a log, we can directly make some jumps. So we can update like dp if I plus j is the jump length, is minimum of current value of dp comma dpi, where dpi would be how many times we took to jump to the ith element. And ensure that you don't jump on log. Do not jump on crocodile, sorry. Jump on crocodile. And if you are on water, like you don't have a choice but to swim once. So you can do dpi plus 1 is minimum of whatever current value is and 1 plus dpi. And at last check if dp n plus 1 is less than equal to k. And that was the solution I had. So like we ignore value of k first, and at last we take what is the minimum number of swimming time we need to reach n plus 1. Like I think the solution which Neil mentioned was like instead of directly making a jump of length m, if there is a log somewhere, you move to the nearest log and then you keep continuing, and that solution should work. Like if there is some log between like the jump you are making, then go to that log instead of directly jumping water m meters away, the farthest possible log you can get. No, like problem statement like definitely was confusing here. Like it says if he is in water, he can swim to the next segment, river segment, or to the bank if he is at the last meter. So if you are at last meter, you can also go to the next segment. And river segment is probably like any segment which is either crocodile, which you are not allowed to, but you can go to next water or log there. Yeah, like that is also an idea. Like instead of going farthest log, just go to the closest log. That should also be fine. So my solution was like I just added one log in starting at index 0 and one log at index n plus 1. Because on the bank also what you are doing is you are just jumping whatever you want there. So for all j equal to 1, if current position is the crocodile, you will have to swim infinite times to reach that position. If you are on water and if you have a next segment, you can do dp j plus 1 is minimum of current value of dp and 1 time swimming from j and continue. Otherwise, you are on a log, so you make a jump of t from basically t is the jump size from 1 equal to m. T plus j would be your new position. Ensure that new position is not outside the grid. Nj is the new position. If this new position is crocodile, ignore it. Otherwise, I simply assigned it. You can also take a minimum here. Like I think here I am essentially doing the greedy part here. And like another way, like the way I described dp, like this should be minimum of nj comma j here. And at last, take the jump required to reach final swimming required to reach final position is less than equal to k. Print yes, otherwise print no. Any questions on problem D before you move further? Like the problem with recursion is like you can get a TLE. Recursive solution can give you a TLE, and like that is the only problem. I was using DP to minimize it. Can you explain to this solution? Yeah, I can take a look at it once. Yeah, you can probably try to optimize space because the size is 10. Instead of using a vector of 10, you can use a vector of length 10. That can be done. He also added logs in starting and end. If you are at a log, find a farthest log you can go. Yeah, so like tourist is essentially doing this. Let's say these are the places with logs here. What he does first is, if he is here, he checks what is the maximum jump he can go. This is length m. If there is a log in this, then he jumps to that log and keeps continuing. And if this is the length m and there is no log here, then what he does is he starts swimming from here to go at the end. And if this position is a crocodile, then the answer is impossible. Yes, you can go from log to water. Log to water is allowed. Water to log is allowed. Just anywhere from crocodile is not allowed. And from crocodile, because you can't reach, you obviously can't go anywhere. So like I am not aware of the internal details of DQ, to be honest. So like I won't be able to comment like what is the default size of DQ, etc. there. And that is what Tourist is doing, and that is what Neil told us in the chat as well. So problem E, definitely I found it to be the hardest one, and like it took me quite a long time to get it right. It says one of the first programming problems by K looked like this. N has N friends. Each of them gave him A apples for his birthday. Delighted with such a gift, N returned B apples to his friend. How many apples are left with N? K wrote a solution but accidentally considered the value of N as string. So the value of N into A minus B was actually calculated differently. When multiplying the integer by A, he will get string concatenated N times. When subtracting integer B from string, the last B characters will be removed from it. If B is greater than or equal to the length of string, it becomes empty. Learning about this, E became interested in how many pairs A and B exist for a given N, satisfying the constraint of the problem which K solution gives correct. The solution gives correct means that it outputs a non-empty string, and this string when converted to integer is the correct value of n into a. Like, I don't think the test cases were particularly bad, just that I did not like the problem statement. And like problem statement involves guessing. People would have tried to probably explicitly prove it, but I was not able to come up with any explicit bound. So my solution was mostly to guess. If what problem statement it says is like we have some integer n, a and b. One value we can do is like we can find this value here. Like let's just take some examples that will make it easy. Let's pick 3. Let's pick 2 and 20 and 18. So like 2 multiplied by 20, it says is written like this. 20 times a character like this. And then you subtract 18 characters from here. Whatever value remains is 22. And what we can also do is like we can separately look at 2 into 20 minus 18, which is also 22. So if both of these values are equal, this value which you have first written something and then you have removed the digits, and the actual value of n into a. If both of these are equal, then we say it's a bad test case. And it essentially says basically find number of such problems like this. And like to output it says like for each given integer n, find all the possible values of ai and bi like this. Print those values, like first print the count of how many values you are going to print and then print those such integers there. So for example, a20, b20, if you put a 20 times, a string like this becomes, and then when you remove 18 integers from here, 22 remains. And coincidentally, this 22 is also equal to 20 into 2 minus 18. And we have to print pairs like this. And like that is the solution. And like one thing you can see is like for n equal to 1, for n equal to 1, concatenating a means a would be there and 1 would be there a times. And if you take b equal to a minus 1, you would delete all these from here. And you would be just left with 1. So the idea is for n equal to 1, print all the values of b equal to a minus 1, which is within bound. And in the problem statement, it was given that a is less than 10 to the power 4 and b should also be less than 10 to the power 4 minus 1. So this essentially means printing all the possible values there. So like for n equal to 1, we directly print b plus 1 and 1. Just to ensure that a is between this and b is between this, we just print like 9 times 4, not the all 1e4 values there. And for other thing, what I essentially did was I just tried to brute force it. I assumed, yeah, like I essentially means like a is less than equal to 1000 is given to us. A is less than 10 to the power 4 is given to us. And n is also less than 101. And b is also 10 to the power 4 and 1. So like what is the maximum value of original value of n into a minus b? Like this value should be less than 10 to the power 6, right? Like I like essentially like for n equal to 1 only I found this. So what we know is and number of digits here are less than equal to 7. Right? So like we can first fix the number of final digits there. Like let's say n equal to 10 and we want 5 digits. Like basically there would be some string initially and then some numbers would be removed from here. So if only 5 numbers remain, then they would look like this. Right? Then you can essentially try out all b equal to 1 to 10 to the power 4. Like this is the final value you would have. If you say that like the finally number of digits remain would be 5. So like let's call it result. So result, which if we fix number of digits, the value of result is also fixed. N is also fixed, A is also fixed, and like we run a for loop b equal to 1 to 10 to the power 4. Then if we move b here and n divided by 2, it becomes result plus b by n, which is A. And now we can check like what would be the actual digits we would get over here. Like we also know number of digits of n. So we can say like overall if dn is the number of digits into n, multiplying it will give us this digit and removing b digits should be equal to like 5 here in this particular case. And that is the brute force solution we can do here. Like I will probably code it better than what I did in the contest because I missed like a is less than 1e4 here. First, if it's 1, then print all the possible values. Let's say 9. Keep adding n in the string form here. Let's fix the number of digits. Then like we also know like we can use stoll method to convert string to long int. This is the final value of b we want. B is 10 to the power 4. N multiplied by A would be res plus B. If n is not a multiple of n, continue. Otherwise, A would be equal to res plus B by n. We also know like size of D. This would be the length when you multiply it by A. This would be the length when you remove last p digit. If this is equal to the initial length we fixed here, then answer pairs dot pushback A comma B. And like this sorting was just I think not required. and like at last print all the pairs you have got. And like this is the solution we have. Any questions on problem E? Like probably had I focused on value of A in the problem statement, I would have been less annoyed by it. I am going to start problem F, Aditya. Any questions before we move to the next problem? Problem A says valuable cards in his favorite cafe K once again wanted to try hearing under a fur coat. Previously, it would not have been difficult for him to do, but the cafe recently introduced a new policy. Now, in order to make a purchase, K needs to solve the following problem. Like, does not make any sense so far, but just a part of story. N cards with prices from different positions are laid in front of him. On the ith card, there is an integer ai. Among these prices, there is no whole positive integer x. K is asked to divide these cards into minimum number of bad segments so that each card belongs to exactly one segment. A segment is considered bad if it is impossible to select a subset of cards with product equal to x. All the segments in which K divides the card must be bad. Formally, segment L to R is bad if there are no indexes I1 in the increasing from IK, where I1 and IK both are between 1 L to R and product of all these numbers is X. Help K determine minimum number of bad segments in order to enjoy his favorite dish. So first thing first, like what is the problem statement asking us to do? A lot of definitions were involved here. What it says is a segment A to A3 up to AN is given to us. And an integer x is also given to us. And what we have to do is we have to divide it into some segments. Such that for every segment, let's say this is the segment we have chosen. BL to BR. If we pick some random numbers from here, some numbers from here, if we now in every segment, if we fix some numbers from here and look at their product, it should not be equal to x. And this should hold for every such segment. Like there is no way you can get product equal to x by picking up some numbers from each segment here. And it says you should find minimum number of such segments. So any questions on the problem statement before we move to the solution for this? No, I don't think like storing all the devices can be had. Like one thing to notice was, so like moving on to the solution. So the idea is like we will keep increasing our right border and let's say we have AR somewhere. And we look at some segments here. First thing first, again, let's define something known as DPR. This is minimum number of segments where we can divide A1 to AR into some number of segments. Now, if we have some fixed AR, if we look at the segments over here, there would be some range up to which we cannot get product X. Then there would be a segment, first time a segment where we will get product X. And after that, everything will give us a product X. Because like, let's say these are the elements which gives us product equal to X. And this is the largest such possible starting element. Yes, segment must be continuous. So what we know is like for every element, up to some range we cannot form product X. And then there would be some set using which we can form a product equal to X. And after that, for every element that would be there. So if for every R, if we can somehow find the maximum value starting with there is no product X, then what we can do is like we can say DPR is minimum of 1 plus minimum of, like, let's say this is the maximum index L up to which we go from here where with no product X. Minimum of all the values I which is greater than R. And essentially that was the solution I had. Like for product X, it means a subsequence, but for the dividing, it means segment. So division must be in continuous segment, and in any segment you can pick any numbers, they need not be continuous. So the idea is how do we find this element L, because once we know this, the other solution becomes a bit easy. My idea was, like some people mention they use set, etc. Like that can be one solution. Like we can let's say we have a dp2r and some element f as the maximum value. As the maximum value, if you start from there, you can get product equal to f in this segment for some range. And that is how I define something. dp2r, f means what is the maximum index which we can take, such that if we take this range, we would get some elements with product equal to f. And you know, like the L we were talking about was essentially equal to dp2f x, and we need plus 1 extra there, somewhere from where we can start. And the idea was like in this dp we only keep factors of x. And the critical thing I noticed here was, if you look at all the numbers from 1 to 10 to the power 5, the maximum number of factors is 128. So overall, like your time complexity would be n into 128 into log of 128, which is around 7 or something, and this is within the time limit. So no TL here. And like a lot of people estimate number of factors as n to the power 1 by 3. Like it is very loose estimate. Like the one key rule I do is, if I want to find the number with maximum number of factors up to something, I start multiplying consecutive prime numbers starting from 2. This is still less than 10 to the power 5, 11, 13. Like I think this is some number we can probably check. Up to 17 it becomes 5 times 5. This value is this or 5050, something like that. I don't remember the exact value. So like now this number has number of factors, like this can either be taken or not, taken or not. So like overall possible prime factors you will get is 128. Because for each prime number you have choice, either you take it or not, and then here there are 7 primes, which is 2 to the power 7. So find the first product which makes product greater than 10 to the power 5, and this is what you will get. And if you want to be more specific, instead of 17 you can take 2 to the power 3. Like this is the key rule I use to estimate what is the maximum number of factors can be, and this is generally accurate with the multiplying factor of 2 or not. So like generally if number of factors is 180 somewhere, I either get 128 or 256 using this method. So if you look at 8 into 3 into 5 into 11 into 13, this is 12012, and this number has 128 factors, and probably I believe this would be the first number with 128 factors. Or one more idea you can use, like if you don't want to go via this route for approximating, you can just search highly composite numbers. Basically these are the numbers with maximum factors. Yesterday like we looked at prime gap table, something like this in codes of contest. So like this has increasing number of factors in this list. So like up to 1E5, probably 144 is the number of factors, and this number has 128 factors, and this is less than 1E5. So you can just look at what is the larger number greater than 1E5, which is 144. So you can assume that all the numbers are less than 144 factors or 128. And like that is one more thing you can use. Any questions so far? Before like actually finding, like so far we have estimated time complexity. We have came up with one idea using a set or map which you can solve probably. But we have not yet decided, like, we have seen how to calculate DP2, but we haven't decided how to calculate DP1 yet. So like DP1 I will jump onto it, but any questions so far? So the next idea is, now we are iterating on increasing order of r equal to 1 to n. For each r we know some number l. If we take that, we will find a number with product equal to x. and what we need is minimum value in this range. Like DPL denoted like we have taken numbers out there. So like if we bifurcate here, so if we start from some k here, what we need is 1 plus dpk minus 1. And we need minimum value. Like in the context, I use segmentary, but you can also use a priority queue here. Look at the number with smallest, like in priority queue, you push value of dpi comma I. And if it matches priority queue, subtract minus 1. Basically, find the smallest value. If this I is outside the range, remove it and find the next. You can keep going. So like I will probably code this. In the context, I use a segment, but we don't really need a segment. First, I have taken all the inputs. I have found all the factors. We don't really need factors. DP2, which I defined earlier. Okay, how is the voice now? Like I probably bought mic near. Hello, hello. I did bought mic near me, like it was relatively far from me. Does this looks even? Does this look better or like something I should try out more? Hello. Okay, thanks, Amol. Yeah. So what I will do is current element like one based indexing. So just took one. Like set can be the other way, but yeah. One thing we do is like we can get current element product at index R. If we extend this segment, this becomes PVR product into current element. I called it M instead of X in the problem statement. If M does not divide current element, we can ignore it. We also add like if we do not use current value, then we can just assign it whatever earlier indexed they were. Current product, comma whatever index we have. This is the min priority queue. And the maximum index up to we can go would be current into whatever value of m we have. Like we should also push 0 here. Priority queue will never be empty, to be honest. If priority queue dot top dot y is less than L, pq dot pop. Keep removing all the elements with min value which are less than the current index. Are equal to 1 plus pq dot top dot x, and pq dot push would be less r comma r. Res is like the final dp vector we have. So this is my solution for this problem. This should be current element. Like I am mostly done with F. Okay, I forgot to add like, no, I did add current element here. Right? It says it fails somewhere here only. And it should be one base index selection. Okay, yeah, BP, this should also be n plus 1. Okay, it passes all the samples. So this was my solution for problem F. Any questions on this one before we move to problem G? That would be the last problem. Okay, memory limit exit like this might be because we are using probably a lot more. Oh wait, if current element divides product, then only we should add it. Otherwise, like the solution is n square. Makes no sense. This will get a TLE. This should be fine. Wait, why man? Like, let's just keep clearing preview. Like in the contest, like I ended up using array instead of product, and that was fine. Time limit is 4 seconds. Right? Yeah. Any questions on problem F? We move to before we move to problem G. Any question so far? Problem D says Ultra-Meow. K gave you an array A of length and consists of in numbers 1 to n. Accept it, of course, but what to do with it? Of course, calculate meow A. Max x comma b is the kth positive. Like generally in the definition of max we include 0. Here it's saying you should not include 0. Kth positive integer in ascending order that is not present in the set S. Like the space complexity of PQ is size n only. Like you don't push, you insert only n times and you remove some elements from there. So it won't be more than n, order n. That is not present in S. Denote meow A as sum of max of like basically over all distinct subset B of the array A. So first it says max x comma k defined as S is a set given to us. Find the kth positive integer that is not present in it. So to give some examples here. Like for example, we have said 2, 3, 7. Then there are 3 elements in the set. So the smallest element not present here is 1 positive integer. Then 4, 5, 6, 7, 8, 9 and so on. So max of S comma 3 would be the smallest third element which is not present here, which is 5. And then the next thing was in the problem statement it's defined as first it says we take a set B which is subset of all the numbers from 1 up to n. Then if you find max of B comma length of B plus 1. So in this case you have 3 elements. So you should find the 4th element that is not present in this set. Fourth element would be 6. And among all the possible 2 to the power n such sets, you should calculate that max values sum here. Any questions on problem statement before we move to the solution? So moving on to solution. Let's say like we have some numbers. Let's look at all the numbers from 1 to up to 2n plus 1. Like if you choose all the numbers 1 to n, you need n plus 1th number not present in the set. That would be 2n plus 1. So whatever value we need will never be more than 2n plus 1. The idea is, let's say like the value we need is some j here, which is max of whatever size we defined here. And let's say we have chosen s numbers from here. And up to n, we have chosen l numbers from here. Looks fine, right? There would be some value of max which we have chosen, like which we would get when we try to find whatever value we want. And there will be some number less than the final value, and there will be some number larger than the final value. Looks fine, right? And like the idea is I will iterate on all s from 0 to n. That is the maximum number, small number you can choose, and all the small and large number we would get. Looks fine, right? And if we look at this set now, the remaining count, like j would be like the value we want of max of b comma size b plus 1. So like this would be some value which we will get as a max. So here remaining number of elements would be j minus s, right? Like these are the number which are not chosen in the set. And this should be equal to size of b plus 1. Because if you want fifth number not to be present in the set, then there should be 5 number here. So the idea is if we write j minus s equal to s plus l plus 1, then j would come out to be 2 into s plus l plus 1. What this essentially says is, if you fix the number, that should be the given max. And if in your set there are s numbers less than that and l numbers larger than that, then this value would be equal to 2s plus l plus 1. Any questions so far? Then the next idea is, we can look at how many numbers are present here. Either we can choose everything from 1 to m minus 1 or 1 to n, like whatever be the case. Among that, we should let that count be t. We should choose c, t comma s small numbers. And if this m is less than n, then there would be n minus m possible numbers here. So we choose C of n minus m comma L here. And that was the solution. Now you iterate on all s equal to 0 to n and all L equal to 0 to n. And that is the solution I have. I can probably code it now. Like we need like NCR calculation fast. So like I have pre-computed all the factorials and inverse factorial so that I can compute NCR in order 1. If I have S numbers, small numbers, and if L numbers are large, then required max value would be equal to 2 times S plus L. Then small available numbers would be either N or what is required max we have. Large available would similarly be max of N comma and number of ways would be NCR into whatever small numbers we have and whatever small numbers we want to take into NCR large, whatever large numbers are available and the large number we want to take. Required max into number of ways we want and print that value in the end. Like you might want to check like this if small available is less than S or large available is larger than L, then the answer is this case is impossible. So that is something you can do, but my NCR used to give 0 for such cases, so I did not need it. And like this kind of gives a hint that something order n square time complexity would be required here. So I think with this we are done for the today's stream. Any questions related to any questions in the chat or any other question you guys have? Like I would be happy to answer it. So like I am using Ekner-Wala these are the two scripts I am using. Along with this competitive companion exists. This competitive companion exists extension. So like these are the three things I am using. Like this extension is used to pass test cases and like this is the script which looks at the extension and creates a directory with the sample test cases and your template in it. And this make file I use to test it out. Any other questions for people in the chat before we call it a day? And like thanks everyone who is here so far. Like, do you like to code in lead code? Like, probably like I don't really have a good setup for lead code. Like, I just copy it down and I have created one simple file which runs main file, etc. to do it. Thanks everyone for joining today. And I think I will end today's stream now.